much for having me. So I'll be talking about the National Nextflow Service for Australian researchers. And this project is one of the Australian Biocommons project, and it's with collaboration with POSI and NCI. So the aim of the Australian Biocommons is to support life science communities with community scale digital infrastructure, and that includes software and hardware platforms. We also have training and support solutions. We are nationally funded. We aim not to replicate efforts, and all our services are fully subsidized for researchers. And this project, the Nextflow service, was as like a response to the interest of the Australian researchers in utilizing Nextflow, which is workflow management system. And the service is based on Nextflow Tower technology, which is a web platform to run and monitor the execution of Nextflow pipelines. And the users can benefit from the service in 3 different ways. One of them is to access personal workspace, which is like a workspace dedicated for one user. You add your pipelines, compute environments, and you start to utilize them. The other way is the organization workspace. And with this workspace, you can have multiple users so they can share the resources and collaborate together on this. And the third model is what we are trying to do is the analysis service, where for some commonly used pipelines, the same Biocommons will deploy these pipelines on a shared workspace that's accessible to all users on the platform. And we'll also be providing compute infrastructure in behind. So from the user perspective, you only need to bring your data and run these pipelines on our compute infrastructure, get the results, and do whatever downstream analysis you want to do. So we started this project around, I think, in June 22. And by today, we managed to onboard 61 users from 17 different organizations to the service. We also managed to do like successful integration with our partners' infrastructure, including HPCs at POSI, NCI, some on-premises HPCs, commercial cloud as well, including AWS. And the plan is hopefully to have the service in the production mode available to our researchers at the first half of the next year. Here are examples of the current users we have. So we have some research groups from WIHI, Telephone Kids Institutes. We have some research from the University of Sydney, QUT. We have also some consortium like Ozark as well. And as I mentioned, so we are still in a pilot project with the service, but the service is accessible, so anyone can just log into the service and start to utilize the personal workspace. If you need an organization workspace, just reach out to us. We'll create it for you quickly, and you can start utilizing the service. However, like the best way to do is actually to have some stuff ready before, or at least when you are exploring the service. And what you need is actually access to compute infrastructure, like national or institutional HPCs, commercial cloud as well, if you have. And some of the programs that Australian Biocommons can maybe support with aspects if somehow you fulfill the criteria they have. You also need at least a Nextflow pipeline implemented, tested on the compute infrastructure. You need a data set as well, like just to make sure that the integration or the deployment of the pipelines are successful, and also dedicated Nextflow expertise. So you lead and maintain the development of your workspace. And from our side, we try to help you and support you with whatever we can. Recently, in late October, there was the Nextflow Summit in Barcelona, and Secura Labs, which is the company that developed Nextflow, they announced major changes and improvements. One of it is actually they rebranded Nextflow Tower to Secura Lab now, to Secura Platform. And they also announced like improved and new technologies, including Fusion, Wave for like container provisioning, and multi-QC as well. They also added Data Explorer and Data Studio to Secura platforms. And there were many contributions to the NF-Core communities, including pipelines and plugins. So I have a short demo just to show you like an idea about the service. So that's the web page after you log in. You will land to this workspace. We have it for demo, and this is like pre-configured workspace. Here you can access all the participants, the users you have on the workspace. Some of them, they have like full control over the resources. Some of them, they only view. You can move to the credentials where you set up access to different platforms, including like GitHub, for example, to access your private repositories. You can set up access to the HPC, to commercial cloud as well. Then also you can configure the compute environments you have based on the credentials you created. And here I have a few compute environments on Citonex, or sorry, in POSI, on Spartan that we see at Unimel, on AWS as well. That's the interface where you have your pipelines you configured. That's a pipeline we developed with a GRF. It's a hi-fi genome assembly. When you want to launch this pipeline, you click on the pipeline, and it will take you to another page. Here you can see, so all the pipeline parameters are actually in a user interface, so you can just change them and customize them easily. You also can go to the launch settings. So when you click on the launch setting, you can now customize the compute environment or pick which compute environment you want to run this pipeline on here. Here we do this test on AWS, and we put the configuration for AWS, including Docker for containers. You click on launch, and the platform will start submit this pipeline to the compute infrastructure and start working there. Now I'll show you a report of a successful run. So that's what we will be seeing when you run the analysis, and at the end we actually just run Nextflow command on the compute infrastructure. You can as well, you can access the parameters of the executions. You also can access the configuration datasets if you have. You can also see the execution log of the main Nextflow process. And when you are actually running this pipeline, all this information will be updated live, like with the progress of the pipeline. You can see the status of all the tasks submitted by the pipelines. You also can link them down with the specific processes, so you know specifically which task is successful, which one is failed, for which example. You have some aggregated stats as well about the pipeline execution. All this, some general information on the user, which compute environment you're running on. You get like general overview of like the wall time you need, the memory, and also like an estimated cost if you want to run this pipeline on commercial cloud. In the table below, you will get more details onto the specific tasks of the pipeline. And these ones, like we see, the status of all of them, the exit code, the containers you are using. If you click on any of them, you will get more details on the specific tasks, including all the resources that this specific job used as memory and everything. But you also can access the execution log. And as I said before, when the pipeline is running, all this information will be updated like live when you are running this. You also get some like aggregated results for some of the resources usage, including the CPU time, and that's like box plots usually. So each process, for each process across all the samples. But in this case, because we have just one sample, sorry. Thank you. So these are the main features. Well, not the main feature, like the core functionality of the service, but there are so many features, especially with what they improved recently as well. Here are the links for more information if you want to access the service. If you want an organization workspace, please reach out and we will help you with this. Thank you so much.
Thank you so much, Ziad. Do we have any questions for Ziad? I'll start with one question. Oh, there is one. Yep, you go.
I was just wondering what the costs involved are for like an organization versus a personal setup.
Well, all the services are fully subsidized by the Australian Biocommons, so there is no cost on Australian researchers.
So providing you're part of a university, you're good.
Yep. There's no problem. The personal organization, sorry, the personal workspace, you can just log into the service and you will get access directly.
Thank you.
No worries.
Okay, and time for one more question.
I had just one question about, say, importing a Nextflow pipeline onto the platform. Could you, say, for example, set up input validation to restrict what type of values the user can have as parameters, and then maybe it throws error messages and stuff like that? If I understand.
But do you mean to throw these error messages on the platform itself?
Yeah, I'm just wondering how that handles, like, just to make sure that people are using the right parameters for the pipeline.
Well, I think you can have the right, like you can do the validation at the pipeline level, but I think that will be more happening on the compute infrastructure after you run the pipeline. There is nothing happening on the platform like as actual analysis. So the platform is mainly submitting, this job to the back end, and it starts the next flow there. Then I believe all the validation that you have in your pipelines will happen there. And if there is an issue, it will just retain an error, and you will, kill the execution, but you will see the error message here in the logs.
Ah, cool. Thank you.
No worries.